So in this video, we're going to talk a little bit about motion and kind of how displacement, velocity, and acceleration are related. This might make a little bit more sense in later chapters after we learn how to do an antiderivative. And generally, we're not usually going to start with the displacement equation in the future. We'll probably start with acceleration and kind of work our way backwards. But since we can start with this in chapter 3, the main thing you need to realize is velocity is the derivative in terms of time of displacement, x of t, some sort of displacement. This will be x, this sometimes is s, depends on what kind of you're using for, but it's the derivative of displacement. Alright, now it's pretty easy to tell. I mean, if you think about your units for cars, like think about miles per hour, miles over hour. You take your miles and divide it by hours. So you're taking your displacement and putting it over dt, dividing it by time. Now it's a small change in displacement, d displacement, over a small change in time, small change in miles per hour, over a small change in time. So that's why it's instantaneous. That's why you do the derivative. Now the acceleration, basically that's going to be your derivative of your velocity. So if you think about that, that's how fast your velocity is changing. Okay, so to take the basic thing, you take your displacement, you take the derivative, and that gives you velocity. You take that derivative, and that gives you acceleration. And then later on, after chapter 4, we'll start going backwards, which means you'll be doing the antiderivative of acceleration to get velocity. You don't really want to try to jump from displacement to acceleration. You have to go through velocity. Alright, so let's see how that works out here. So we've got this particular problem, and we have a height, which is a displacement. Okay, and it's given by this. Velocity and acceleration functions. Okay, well, the velocity function would just be the derivative. So that's equal to, well, 10 basically cosine of 2t, and we lose the 20. Acceleration would just be the derivative of that. So negative 20 cosine, oh, sorry, was cosine, sine of 2t. That's really it to find the acceleration and velocities. If we want to find the speed, okay, well, I think that's a little bit tricky about speed. Speed is not necessarily velocity. If we wanted to find the velocity, it would just be this. Okay. Now, think about if you're driving in a car. If you're going forward, your speed at 30 miles per hour. If you're going backwards at a speed of 30 miles per hour, your speed's still 30, but your velocity is either positive 30 or negative 30. So when I want to find speed, and I just have a single direction velocity, and later on we'll talk about velocity in two directions, such as something being shot out like a cannon, where you have a velocity in the x direction and a velocity in the y direction. To find the speed there, you're basically going to do the Pythagorean theorem to find the resultant speed. Over here, since we just have one direction, it's just going up and down as Wilson's floating in the sea, you take your velocity and you really just use the absolute value of velocity for speed. So in this case, we're going to do the absolute value of 10 cosine of 8. Now, if cosine of 8 happens to be positive, then it doesn't do anything. But if cosine of 8 is negative, then you use the absolute value. Okay, so that's really it to find speed. If I want to just find velocity, you just plug in 4. That would be it. When is his speed increasing? Now that's a really tricky question. Speed increasing. Okay, well think about this. If you're driving in a car, you're going forward, and at the beginning of your drive, you're accelerating, right? You're going faster and faster. And then at some point, you stop. You're no longer, your speed's not going faster. It just kind of slows down and you're still going. So like your acceleration stops, and your velocity keeps going. So think about this. You accelerate up to 30 miles per hour, and then you just keep coasting at 30 miles per hour. Your velocity is still positive, but your acceleration stopped. Okay. So over here, when both your acceleration and your velocity are positive, you're speeding up. Now, let's see what happens here. As if the acceleration is negative, is your velocity really going to negative right away? Oh, think about this. Acceleration just means you're slowing down up until the point where you hit a stop. Okay? You stop at the stoplight. Now, after that, if you accelerate again, you're speeding up, right? Both positive, you're speeding up. So in this place, we're speeding up. In this place, we're slowing down. Now so it sounds like so it looks like if acceleration is positive, it's speeding up. But let's think about this backwards. Let's say you start reversing, and we'll put acceleration at the top and velocity at the bottom again. So we're going backwards. And if you think about this, we're going backwards and we're accelerating backwards, right? We're here. Let's say we drove to the store and then we realize, oh, I left my textbook on the top of my car. I gotta go back. So you start accelerating backwards and your velocity is going backwards. So right now you're speeding up. You're looking out the rearview mirror, but you're speeding up. At this point, you stop accelerating and then you start to decelerate, which means you actually go forward. Your acceleration is actually positive because your velocity is in the negative direction. So this place you're starting to slow down. So here's the key. When is speed increasing? When velocity and acceleration have the same sign. Alright, so what do you have to do that? Well, you have to look at your velocity equation, you have to look at your acceleration equation, and you got to figure out where their signs are changing. So what that means is you're generally going to set this equal to 0. Now I know that 2t is kind of tricky, so really what you want to think about is where cosine of t. So treat 2t like x, or treat it like t. And cosine equals 0, and that's at pi over 2, and at 3 pi over 2, and at 5 pi over 2, etc., etc., etc. So when it's t, it's going to be pi over 4, 3 pi over 4, 5 pi over 4, etc. Okay, so all of those. So if you take your 2t and just divide it by 2, you're going to have it. So you have a lot of the pi over 4s. Alright, so once we've got that, we're making a velocity chart. So here's v of t. We're going to put our numbers on there. Pi over 4, 3 pi over 4, 5 pi over 4, etc., etc., etc. We're also going to make an acceleration chart. And we also have to talk about what the signs are between them. Alright, so let's talk about that really quick. So you got to think about a value in between pi over 4 and 3 pi over 4. Well, there's 1 pi over 2. We're missing 2 pi over 4 or pi over 2. I'm going to check pi over 2. The nice thing about sine and cosine functions, they fluctuate. So once I have one, I can get all the rest of them just by alternating signs. Okay, so what we have to do is figure out what velocity is at pi over 2. So if I multiply that by 2, I end up with 10 cosine of 2 times pi over 2 is pi. Well, cosine of pi is negative 1 times 10 is negative 10. So it's negative, so that makes that plus, minus, plus. And unless I give you some endpoints to this, I don't know how long this has been bobbing up and down the sea. Forever? I don't know. It wasn't really part of the problem. So when we write our answer in the end, you really have to kind of figure out, how you want to bound it. And you might have to write an infinite number of them. A quick note before I move on here. If I looked at part D, you can already have this answer. What is the reverse direction? Well, if your velocity is positive, that means you're going forward. If your velocity is negative, it's going backwards. So at all these points. Now you might say, well, just when velocity equals 0? No, that's where you're looking for. It's kind of like an inflection point. Inflection point is not where the second derivative equals 0. It's where the second derivative changes sign. Think back here. Velocity was 0 right here in this picture. If I thought about it, that was like me coming up to a stoplight. I stopped, and then I kept going. Did my direction reverse? No, it reversed here when we stopped and then decided to go back and pick up our textbook. You need your sign to change for your direction to reverse. So this is at pi over 4 plus pi over 2k. And that's basically every single time it's going to do that. Okay, so that's, well, a side note there. So let's finish our acceleration. And so acceleration is basically going to be kind of the other ones. So where's this equals 0? Well, I have 2t, where sine equals 0. Well, that's 0 pi, 2 pi, etc. So the acceleration, when I divide those by 2, it's still going to be 0. But I'm not going to have pi. I'm going to have all the pi over 2's. Now I'm back to pi. 3 pi over 2. Alright, and then, okay, check between 0 and pi over 2. Well, pi over 4 sounds like a good one to check. Oh, said 4, not 2. Okay, well, plug in pi over 4. Well, sine of pi over 4 is really the sine of, well, pi over 2, because we're multiplying by 2. And sine of pi over 2 is 1, but we got to multiply by negative 20. So negative 20 plus minus. Okay, so now you gotta be a little bit careful about this because these numbers don't line up. So what you might want to do, but you gotta be careful about doing this, is if I put 0 here and put them all kind of like transpose them, one good way, and I didn't do a very good job here, would be to kind of line them up. So like 0 right above 0, pi over 4 right above like the middle here. Pi over 2 right underneath where pi over 2 should be. So if you line up the numbers, it's a lot easier to see. So if I go from 0 to pi over 4, I have a negative on acceleration, and I have a positive on velocity, so that's no good. But from pi over 4 to pi over 2, I have both negatives. So both negatives. I like that. But then at pi over 2, my acceleration stops being negative and starts becoming positive. So this is positive, and then up to 3 pi over 4, velocity is negative. But then from 3 pi over 4 to pi, they're both positive. Now sometimes these numbers are going to be the exact same between them, and it's just a matter of finding on the chart what points they have both the same sign. The idea here for speed increasing is you're looking for both the acceleration and velocity have the same sign. That's the key. Same sign. Not that velocity is positive. When is velocity increasing? Well, if that was the question, that would be when acceleration is positive. When is displacement increasing? That's when velocity is positive. So you have to be very careful. You have to keep those in your mind clear, because they will ask those questions and they will switch up the wording just slightly, and it will mean an entirely different thing.